Okay, so we're on the de Broglie theory, part of the Unit 1 practice. So de Broglie theory, let's do it in blue. That can be found on the memorizations right here. All of those questions can be answered by using all of this information. So de Broglie's theory says the higher the mass of an object, the lower the wavelength. So this theory basically says that something with a large mass, like a person, is going to have a very, very low wavelength and it's not going to be able to be detected. So simple estimate is a 100 kilogram person walking 1 meters per second is about 10 to the negative 36 meters wavelength. But electrons and protons are small enough so that their wavelengths can be measured. An electron has a wavelength of nanometers, which is 10 to the negative 9 meters. And then protons have a wavelength of picometers, which is 10 to the negative 12 meters. So we see that protons are larger than electrons in mass. So protons are going to have a smaller wavelength than electrons. So high mass is going to be low wavelength. Okay. De Broglie also postulated that matter also acts as a wave. This is shown in the Foreman experiment where electrons have a diffraction pattern. Okay, let's go back to our questions. So we just went over A, which of the following experience most directly supports de Broglie's hypothesis of the wave nature of matter. So we just answered that one. Which of the following objects have the smallest wavelength at the same velocity? So we really don't have to know about velocity. Remember, high mass equals low wavelength. So you would choose the one with the highest mass. Even though all matter exhibits a wave-like quality, we can really only observe the wave properties of blank. Remember, if it's too large of a mass, we're not going to be able to exhibit the wave properties. We need something like electrons or protons. So which answer is going to give you that? You need size like electrons or protons. Okay? And it just keeps on going and going. The smallest mass is going to give you the highest wavelength. This one's asking for the smallest wavelength. So you want high mass.